Hi, everybody. Welcome to Chapter 9, which is correlation. So chapters 9 and 10 are very similar to each other. Correlation has to do with the relationship between two variables. Chapter 9 is going to be what we normally call a correlation, which is a standardized relationship between two continuous variables. Whereas Chapter 10 is going to be unstandardized. It's going to be the same concept, but just a little bit different. One is standardized and one is not standardized. Normally, when people talk about correlation, though, talking about the stuff we're talking about in this chapter, chapter 9. So in part 1, let's go through the basics of what do we mean by correlation. So first, a review, how to analyze the statistics. Step 1, choose the right statistic. Now, so far we've discussed two basic kinds of statistics that you really care about. One is a categorical with two options that are mutually exclusive. That's the binomial. If that's what you've got, then you use a binomial. Or if you've got one individual score compared to the rest of the population, then you're looking for the z-score, correct? Right? You can also do this for the mean and other things, right? So you just need to know what statistic you're supposed to run. And then 2, you're going to evaluate that statistic based off its sampling distribution. So if the probability of getting the obtained statistic or a more extreme value is less than or equal to your alpha, then you reject the null hypothesis. By the binomial, you can either use the binomial table as the sampling distribution or the normal curve as a sampling distribution if you've got an n over 30. And with the z-score, you use a normal curve. That is your sampling distribution. Today, we're going to add a new statistic to this. So besides binomial, besides z-score, you're also going to be able to do a Pearsons R, which is a Pearson's product moment correlation coefficient. That is what we're going to do. We're going to add a new line to that idea of which statistic you should use and when. We use statistics. In our class, we're only talking about bivariate statistics, and we're only talking about a linear relationships. So when you have two continuous variables and their relationship is assumed to be linear, then we are looking at a correlation, which is what, well, anyway, we're going to use the terms correlation, meaning a bivariate, two variables, and they're going to be continuous. You cannot do the correlation that we're about to do with two categorical variables. You cannot do the correlation we're about to do with one categorical variable and one continuous variable. It's got to be exactly two, and they both have to be continuous. All right, not three continuous variables, two continuous variables total. That's it. All right. Let's give an example. Hey, you remember this? You remember this from like 6th grade, except that we use different letters, right? This is the equation of the line. You might have had y equals mx plus b, but we do y equals bx plus a. It's the same concept though. Same concept, just using different letters. So y is the value of one variable, x is the value of the other variable, and what we're trying to do is figure out the value of y based off of x. So for example, let's say that x is going to be one variable. Let's call that days, right? And I want you to predict how many days excuse me, based off how many days, I want you to predict y. Y is a new variable, it's weeks. Okay, let's see if this is going to write for me. Y equals, come on, y equals weeks. All right. A is going to be the y-intercept and b is the slope. So when you used to do mx plus b, m was the slope. Well, now we're going to call that b. And a is going to be the y-intercept instead of what you normally called b in the past. But it's the same basic idea of what you used to do, right? So you got this y-axis and you got this x-axis going on. And we're going to create a scatter plot. That's exactly what we're going to do. We're going to get weeks. And then we're going to do days. Okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Let's just make sure we can go all the way to there, right? Okay. And then the number of weeks that have passed are going to be 1, 2, 3, etc. Turns out that one person, hey, 7 days passed, and that was exactly 1 week. And then 14 days passed, and that was exactly 2 weeks. And what you're looking for is the line, right? And you're saying, well, 0 equals 0, so we're making a line. Now that line is supposed to be straight. My straightness is not very good with making the lines, but that's supposed to be a straight line. Easy, right? The idea is that for every 7 days that you pass, you go up exactly 1 week. So what is the slope for this example of days and weeks? The slope is going to be 0.14, right? 0.14285714. It's 1/7. It's 1 divided by 7, because as each day passes, for every 1 day, right, one value of x that passes, we go up exactly 0.1429, which is 1/7 of a week, right? So for each 1 day that passes, we go up exactly 0.12, roughly 0.14 weeks, right? So the slope would be, the slope in this case, b, is going to be 0.14. All right, 0.14. Whereas the y-intercept, if you have 0 days, how many weeks do you have? 0. So the y-intercept A is going to be 0. So what you're going to do then is you're going to say, all right, well, if 14 days have passed, 14 times 0.14285714, which is the actual slope, is going to be 2 weeks, right? Normal. You remember this. You remember how this works. Okay, fine. The slope is for every increment on the x-axis, you go up exactly how many on the y-axis. That's what we're looking for. Now, how many weeks if you have 14 days? 2. You have exactly 2. Easy, right? Here's what we're going for when we're talking about relationships between variables. When you were doing lines in the past in like 6th grade, you were doing unstandardized regression, right? Regression just means creating that line that we were looking at. And it was for perfect relationships. Exactly 7 days led to exactly 1 week. That's a perfect relationship. It's an exact amount. We are going to move beyond that and look at imperfect relationships. And we're going to do it in 2 different ways. We're still going to do a regression. That's going to be the next chapter, where we actually figure out the exact amounts of the specific units, right? So when we do unstandardized, what that means is that we keep it in the original units. When we're talking about the increase in days, I want you to tell me exactly how many weeks are going to happen. But in this chapter, we're actually talking about Pearsons R. Pearson, and that's a lowercase r, is a statistic that looks at the relationship between 2 variables. And it's not looking at exactly how many weeks have passed when 7 days have passed. It's asking, what is the relationship between days and weeks? Well, we know that days and weeks have a perfect relationship. They have a perfect relationship. As 7 days go up, 1 week increases. It's a perfect relationship. Pearson's R, which is what we're talking about today, can be any value between 1 and -1. 1 and -1. 1 means a perfect positive relationship. As one thing increases, then the other variable increases at a steady amount. And negative just means as one thing increases, the other decreases at a steady amount. No correlation is a 0, right? 0 is no correlation. And what we're looking for now is, instead of a perfect relationship correlation, we're now looking at imperfect relationships. So what we're going to do is we're going to start with an example of days and weeks looking at a perfect relationship, then we'll do an imperfect relationship later on. You should know that when we're talking about correlations, we have a parameter and we have a statistic. They're basically the same thing, and they're looking at the linear relationship between the variables. The parameter is the Greek symbol rho, whereas the statistic is R, meaning a lowercase r. That indicates the Pearson's product moment correlation coefficient, which is often called Pearson's R, which is often just called correlation. All right? The first step for calculating a Pearson's R is to calculate something called the covariance. The first thing we got to do is calculate something called the covariance. This is not the full This is not the full formula for Pearsons R. The first thing we're going to do is we're going to calculate something called the covariance. Now you should be able to recognize some things here. Now remember, if x equals weeks, so x is variable 1. So let's have x equal weeks and y equals days. I think I did that backwards last time. So I'm going to erase that so we were standardized for what we were before. Let's have x equal days and y equal weeks so that we are doing it the same way we did before. Come on, erase, erase. Okay, x equals days and y equals weeks. All right. Then you'll see here that this should say x bar, by the way. It's x minus x bar and y minus y bar. So x minus x bar and y minus y bar. X bar is the mean for x, so it's going to be the mean number of days, and y bar is going to mean the mean for y's, which is the mean for weeks. All right. Then we're going to add those things up. So you've already seen deviation. So what we're going to do is we're going to multiply. We're going to find each of the deviations. We're going to multiply them, and then we're going to add them up and divide by n minus 1. That's going to give us something called the covariance, which we then use to get the Pearsons R in just a minute. So let's take a look at this and try and do it. Let's keep those for just a second, and let's look at some data. So here's some data that I made up. I've got the number of days since your last vacation, the number of weeks since your last vacation, and then we'll work on fortnights in just a minute. We'll talk about fortnights in just a second. So what we're saying is we need to calculate the covariance. So in order to calculate the covariance, we need to figure out first the deviation for days and then deviation for weeks. Days is going to be x, weeks is going to be y. So I'm going to insert a new variable here, and I'm going to call this one deviation of x. It's going to be the deviation for the days. And then I'm going to do a new variable right here. And that's going to be the deviation for y. And remember, y is the number of weeks. So in order to do this, we got to calculate our deviations. So let's get the mean first. We want this to be the mean for all of the days. That didn't go all the way that I wanted it to. Whoops, sorry. I wanted it to do 6. Yep, that's right. Okay. So this is the mean number of days since their last vacation for each participant. And then we need the deviation for each of those. So this is going to equal x minus x bar. X minus x bar. Now I'm going to put some dollar signs in there so it doesn't move around on me. So the mean number of days since vacation was 35. Participant 1 had 35 days since their last vacation. 35 minus 35 is 0. Now we do that for each one of them, and here's what we get. This is the deviation for participant 2, 3, 4, and 5. All right, great. Now, I don't know why that says Mia instead of mean. There we go. Now we need to do the same thing for weeks. So I'm just going to pull this over. Now, what's going to be the mean for the deviation of x? Oh, it's going to be 0. Look at that, because it's always 0. Has to be. All right, let's move this over so we can see it. Now we're going to do the deviation for y. So this is going to be x minus the mean. So for participant 1, this is 5 minus 5. And I'm going to put some dollar signs in there to keep it in place. And there we go. Here we get each of those deviations. All right, so when you look at these data, you see that we've got weeks and we've got days. Here's the deviations for days, and then over here, the deviations for weeks. Covariance says you take the deviation score. So what I would do is I would take participant 1's deviation score for days, and I would multiply it by the deviation score for Y. And then I'm going to add them up for everybody. So what we're going to do is I'm going to move over one more, and I am going to create a new variable, which is going to be the product of deviations. It's going to be the deviation of X, whoops, come back, deviation of X times, let me move it over so you can see it. Deviation of X times the deviation of Y. So the product of deviations for participant 1 is 0 because 0 times 0 equals 0, right? So let me move this over so we can see this. Pull this down. All right. This is the product of deviations for participant 1, participant 2, 3, 4, and 5. To see them, let me show you what they are. For days, the deviation was 0 for participant 1 times the deviation of weeks, which was 0. The deviation for participant 2 was negative 14 times negative 2. 35 times 5, 28, negative 28 times negative 4, 7 times 1. What we do next is we add them up. So remember, we're trying to get something called the covariance, which is the first step in finding what we want. So let's get the sum. I missed it by not putting in my parentheses. The sum of those is 322. All right? The sum of the product of deviations is 322. Just to remind you what we're doing, let's go back and look at the formula. We are looking for the covariance. Covariance is going to be, first we take the deviation, x minus x bar times y minus y bar, and then we add them all up. So what we did was we took the number of days was x, so x minus x bar for each person, so that's what these deviations are, all right? So those are all the deviations of x, and then for weeks, here's the deviations for y, x, y minus y bar. Here, all of those. Then we took each of those and we multiplied them for each person. So this product of deviations is the deviation in days times the deviation in weeks for each individual. For participant 1, participant 2, 3, 4, and 5. Then we added them all up, we got 322. The covariance is going to be that number, 322, the sum of the products of the deviations, divided by n minus 1. There are 5 participants here, so n minus 1 is 4. So this is going to be this sum of the deviations, product of the deviations, divided by n minus 1, which is 4. 80.5. 80.5. All right? Let's go back to the formulas. So what we just barely did was we took each of the deviations for days. Days was x, so x minus x bar. Now remember, I wrote in a bar over each of those because for some reason the formula didn't show it. Right? We took each of the deviations for days, each of the deviations for weeks, then we multiplied them for each person, and then we added them up. Then we divided that by n minus 1, and our covariance was 80.5. 80.5 was our covariance. The covariance between days and weeks. Now, we did the covariance. Let me show you this, and I need you to not freak out on me. Just be okay, because it's going to be all right. Let's have you do the same process for stress and weeks. What is stress and weeks? Let me show you what I mean. Here, the same data that we were looking at, I have some other variables that I didn't show you before. I want you to take the covariance between this variable, stress, and this variable, weeks. Go ahead and calculate that now. All right, to find the covariance of stress in weeks, the first thing we need to do is make sure that we get our deviation. In this case, stress is going to be X and weeks is going to be Y. So I'm going to insert this. Okay, if X is stress, then these are the deviations for each of these. And so I need to get the average, which is the mean. I need to get the mean of stress for everybody, and that's 7.6. The deviation is going to be X minus the mean. So for participant 1, it's 10 minus 7.6. I'm going to put some dollar signs so we don't move the mean around. So participant 1 has a deviation of 2.4 because 10, their stress minus the mean of 7.6 equals 2.4. We do that for everybody. Here it is. Okay, this is the deviation for everybody. Then we do the same thing for weeks. Now we already have that. Here's all the deviation for the weeks. But now we need a product of the deviation. I'll move it back over here by stress so that it looks the same. So this is going to be the product of each of the deviations for each of the people. So each person is the product of the deviation of stress and weeks. So stress is going to be X, weeks is going to be Y. Here it goes. So this is going to be this deviation for stress times this deviation for weeks. Whoops, I didn't put the times in there. So it's going to be, let me show you again. It's going to be the deviation for stress times the deviation of weeks. So 2.4 is the deviation for stress times 0, which is a deviation for weeks, is going to equal 0. And then we do that for everybody in our group. And there's what you get. All right. Then we get the sum of those deviations, product of the deviations. The sum of the product of the deviations, add them all up. Here's the product of the deviations for each person. We add them all together. Then we take that number divided by n minus 1. So the covariance between stress and weeks is going to be 32, the sum of each of the product of deviations, divided by n minus 1. N is 5, n minus 1 is 4. 32 divided by 4 is 8. Good. Now, This is where you need to not freak out. Once we have the covariance, we can calculate Pearsons R. Now, Pearsons R is the actual statistic that shows us the relationship between the two variables. This looks like a lot of stuff. These are 3 separate ways that you can calculate Pearsons R. You do not have to do all of them. You can do any of them. In fact, this bottom one down here, I like never do that one, right? This says, hey, you got the covariance already. Now divide it by the product of the standard deviations. But if you don't want to do that, then mathematically it's exactly the same to take the z-score for each variable, each person in the variable, multiply those, then add them up and divide that by n minus 1. It's either or. You can do this one, or you can do that one, or you can do that one. Either one that you want. We're going to start with the covariance example, and then we'll do some other ones, all right? So let's start with this covariance. So we calculated the covariance. We took each of the deviations, we multiplied it by, we took each deviation, we multiplied it by the other deviation for each person. Then we added them up, then we divided by n minus 1. Now we got that covariance. So for example, with days and weeks, it was 80.5, right? Now, we need to take the standard deviation of x. So S sub x is the standard deviation of x. In the original example of days and weeks, x was days. So that would be the standard deviation of days times the standard deviation of weeks. So let's do that one. Let's do that one. Let's move things over. Remember when x was days, so there's days, right? Here's days. Days is going to be our x for this example. So standard deviation. So the standard deviation is going to be, you can calculate this on your own. I'm going to get the standard deviation for these data. And this is a sample, so make sure you're doing a standard deviation for a sample. It's going to be 23.74. All right. Now, I'm going to do the same thing. Come on. I'm going to get rid of these in the middle. This is the standard deviation for weeks. This is the standard deviation for days. This is the standard deviation for weeks. Remember, the standard deviation is each of these deviations. You square them, you add them up, you get the sum of, that's the sum of squares. You divide by n minus 1 because this is a sample. Then you take the square root of that, that's going to be the standard deviation. And this is what you should get for days. This is what you should get for weeks. Now, R, Pearsons R, is going to be the covariance, which was for us was 80.5, divided by the product of the standard deviation of days times the standard deviation of weeks. All right? So what we're going to do is let's go ahead and get the product of standard deviations. And that is going to be this number. Whoops, sorry, I'm moving around. It's going to be this standard deviation of days times this standard deviation of weeks. So this is going to equal this, the standard deviation of days, times the standard deviation of weeks. Turns out that's exactly 80.5. R is going to be the covariance divided by the product of standard deviations. It's going to be equal covariance 80.5 divided by 80.5. It's going to be 1. So this is our Pearsons R. Do you remember how when we were looking at the rise over run, right? Remember we're looking at the slope and all that stuff. For every 7 days we increased on the x-axis, we went up 1 week. That's because it's a perfect relationship. An exact amount of 1 is going to lead to an exact amount of the other. Now, it's not saying that it's 1 for 1, not 1 day equals 1 week. That's not what we're saying. We're just saying that the relationship between those variables is perfect. Exactly 7 days pass and exactly 1 week passes. The relationship between those two is exactly perfect. That's why Pearsons R equals 1, because the relationship between days and weeks is perfect. It's perfect. All right, let's keep going on this, do the other example. So when we calculate Pearsons R is a relationship between two variables, the relationship between two variables. If it's a perfect relationship, then you're either going to have a R of 1 or -1. It depends. If it goes up, as days go up, weeks go up exactly the same way, that's a perfect relationship. And it would be positive because as one goes up, the other goes up. If it's a perfect relationship negative, that means as one goes up, the other goes down in exactly the correct amount. No relationship is 0. You can calculate Pearsons R using any of these formulas. They are all correct. Let's do some practice with what we've already done. Now, you've already calculated the covariance for stress and weeks. We already did that one. Now we need to do the product of standard deviations for stress and weeks. So what is the product of standard deviations for stress and weeks? To do this, we go to the data. You remember we calculated the covariance for stress and weeks. The covariance was 8, right? The covariance was 8 between stress and weeks. Now we need to get the product of the standard deviations. Product of standard deviations for stress and weeks. Okay, so let's get the standard deviation for stress. The standard deviation for stress is going to be the standard deviation of these numbers right here. 3.8470, that's going to be the standard deviation for stress. We already have the standard deviation for weeks, it's over here. 3.391164, whatever it is, right? We need the product of those, and so that's going to be equals this, the standard deviation for stress, times the standard deviation for weeks. Where are you? Right there. Is going to be 13.046. 13.046. All right. Then Pearsons R is going to be covariance divided by the product of standard deviations. 0.61. 0.6132. That's going to be our Pearsons R. Okay. Good. Next. Let's do a different example. Covariance of stress and candy bars. Covariance of stress and candy bars. Then we're going to get the product standard deviations. We're going to calculate R. But then we're going to do the same thing doing this for the product of z-scores instead of doing the covariance method. Remember, when we're calculating Pearsons R, we can use any of these 3 formulas and it'll give us the same thing. So let's try for covariance for stress and candy bars. All right, here's how we do this. We've already done the covariance of stress. Now let's do the covariance of candy bars. Sorry, we did the deviations of stress. Now we do the deviations of candy bars. So let's go ahead and add some space for us to do this. We need the deviation of y. In this case, y is going to be candy bars. So first thing we do is get the mean. All right. So the mean number of candy bars is 5. Now we need a deviation for each person. That's going to be x minus the mean. And in order to not move my mean around, I'm going to put dollar signs before the letter and the number. That's an Excel thing. Then we calculate the deviation for each person for their candy bars. Okay. Now we need to get the product of deviations between stress and candy bars. So we're going to insert. Now think about this. Why do we not just add these up and then multiply them? The reason why is because first you multiply, then you add. Please excuse my dear Aunt Sally. In the formula, the deviations are in parentheses. You do the deviation first, then you multiply, then you add them up. So this is going to be the product of stress and candy bars, of the deviations of stress and candy bars. Product cat. So this is going to be the deviation of candy bars times the deviation of stress. We'll go back. And then we do that for each one of the different people. And we add them up. So the sum is going to be $24. We add them all up, we get 24. Then to get the covariance, we take that number, 24, divided by n minus 1. N is 5, n minus 1 is 4, divided by 6. So so n minus 1. So it's going to be 6. The covariance is 6. Now, for us to get Pearsons R, we've got to find the standard deviation for candy bars times the standard deviation for stress. So the standard deviation for candy bars is going to be the standard deviation of a sample. You take each of the deviations, you square them, you add them up, divide by n minus 1, you take the square root of that, and you will get 1.58. We already did the standard deviation for stress. It's over here, 3.847. So product of standard deviations is this, standard deviation of candy bars, times the standard deviation of stress. And you get 6.082, 762, whatever. Pearsons R is going to be this, the covariance, divided by the product of standard deviations. 0.9863, we round that up to 0.99. Now, there's another way we can do this. We can take each of the z-scores for candy bar and each of the z-scores for stress, multiply those together and divide by n minus 1. And we should get the same thing. Let's try it. Let's try it out. So, instead of worrying about the product deviations and all that stuff, we don't care about that. We need to get the z-scores for each of these things. Now, remember, a z-score is the deviation divided by the standard deviation. The deviation divided by the standard deviation. So, I'm going to go ahead and put that on the left just so that you can see it a little bit better. So these are going to be the z-scores for candy bars. All right. It's going to be the deviation divided by the standard deviation. And I'll go ahead and put my dollar signs in there so that it won't move around. And I get a z-score for each of the people. All right, now I'm going to do the same thing for stress. So let me go ahead and enter in a new. Let's see if I can insert a new variable here. Let me move it over just one more. There you go. This is z-score for stress. It's going to be, whoops, move to the first one. The deviation of stress divided by the standard deviation. And then I do that for each person. Okay? Now, what I'm doing, the reason why I'm getting these z-scores is because one way for us to calculate the Pearsons R is to use this formula right here. R equals the sum of z sub x times z sub y divided by n minus 1. So I'm doing this one right now. That's where I'm going. Okay? That's what we're trying to do right now. So we created all the z-scores. Now we need to multiply them together and then add them up. And we'll divide by n minus 1. So let's go back to our data. We are going to need to create a new column. Let's go right here. And we're going to call it product of z-scores. It is going to be the z-score of candy bars times the z-score for stress for each person. There they are. Okay? Now, I'm going to add another variable in here, another column in here, so that we can see this better. The sum of those is move this over so I can make sure you can see. Oops. The sum of these is 3.945 whatever. In order for us to find Pearsons R, we take that number. That's the sum of the product of z-scores. We took all the z-scores, we multiply them by each other, then we add them up. We divide this by n minus 1. N is 5, n minus 1 is 4. And we get 0.9639 Look over here. 0.98639 and 0.98639. When we did it with the covariance divided by the product of standard deviations, 0.98639, whatever. When we did it with product of z-scores, we get the same thing. We get the same thing. This number, let me just move this up, make sure I'm not in the way. This number, 0.98639, that's Pearsons R, 0.98639, the same thing. They're the same thing because they're looking at the relationship and there's different ways that you can add them up. All right, thanks everybody.